Yeah, now we're going to be discussing about some data reconciliation aspects of things. Um, so in the equation-oriented mode, as we all know, there are four types of mode, right? You can see here, we go to the equation-oriented. We have simulation mode, parameter estimation mode, reconciliation, and optimization. We've talked about simulation and optimization. Now it's about data reconciliation. So what we have here is just a simple splitter. So we have 1,000 1 tons an hour of water, split it into 3 streams, and then in this splitter, so we have product 1 and 20%, product 3 30%. So this is product 1 20% and product 3 30%, and then of course this is going to be like 50%. And then we see right 1,000, 200, 300, and then this is then the 500. You can recall. Now the goal is then in this case this 1,200, 300, 500 are the what we call like a model value, and then the goal is then to suppose if we have a field measurement of plant value, and then we want to know how much is actually the flow flowing through these 4 streams if we are trying to match the plant value with the model value. So the way to do that in Aspen via equation-oriented mode is we put analyzer in each of these streams, the ones that we want to reconcile, right? Because we want to reconcile all of these 4 streams, we put the 4 analyzers. So the analyzers comes from the this thingy. So click on it and then put it somewhere on the flow sheet, and then we click one of the analyzer, for example. So I name it like analyzer feed. Yeah. So a reference to the stream of feed, because if you click this drop down, it goes to the we can select any, and then that's how we reference it, and that's basically it. And so we do the same for all of these 4 analyzer. So this analyzer 4, for example, analyzer 3, we reference it to product 3, and then we put like a measurement block. In this case, this guy. So we click on this, put it there, and then in this measurement block, so we define the connections first. So we define the connections. So we create a tag from the plan, for example. So we create a simple tag here, fit in at outlet 1, outlet 2, and then outlet 3, and then this tag, you can add the name description here, and this is the plan tag, and then we connect this tag with the model variable. So this model variable actually you can just once we run the equation oriented, and then we can see for example, we can see once we run the once we run the equation oriented mode, for example, in the simulation, and then you can see what the variables are. Right. Okay, for example, okay, query. I clear the query. Click OK, and then you get So if we say that this feed inlet feed stream is connected to the analyzer, which is in this the mass flow rate of the analyzer. So we connect this to one tag and then the model, and we do for the rest. And then once we define the connection, and then we can say we calculate the offset. So it's by default it's calculating offset, but you can also select the others. You can read what the description is. So calculating the offset means we have the planned value, which we will then put in the values over here, and then we have the model value based on the splitter that we split ratio that we have defined. And then we want to then the difference between the model value and then the planned value is what we call offset, right? So suppose that the inlet flow rate is like 1000, so the same. So the planned value is like the same, and then out 1 is 200, out 2 is 300, as opposed to 500 that we define in the model, and then out 3 is 504, right? And then in this case we go to the input and we calculate the objective. We define, so once we define what the pilot value is, right? So we define the objective functions in the objective under the EO configuration. So we make a objective function, so called the DR. That guy. Yeah. So we use the same term, right? And then just to make it consistent, and then we search for the offset because we want to calculate the offset, right? So we search for the offset for each of the in the measurement. So we go to the measurement. So all this offset for the feed stream, and offset for product 1, offset for product 2, and offset for product 3. So each of this offset, we put like what should be the mean difference between the plant and the model, which is the offset. So as we want to make the plant value, the model value as close as possible to the plant value, so we expect to have like 0 difference, right? So that's why the mean is 0, and then the standard deviations you can put depending on which measurements that you trust more. Okay, so by default it's just like 1 1 1 1 1, right? So we trust all 4 analyzers, and then the physical type is mass flow, and then unit is in kilogram per hour, and then we want to minimize this. Yeah? And then what we can do is that once we set this up, we run not in simulation anymore, but in the data reconciliation. Don't forget to switch it to conclusion oriented, and then reconciliation, and then we select the objective, because I have only one objective, right? Only one objective, the DR objective. Minimize. Once we click, when we create this DR, we are required to say, for example, so we are going to be using sum of squares. That's the typical type of objective function that we use for data reconciliation, because this sum of squares, and we have the difference between the model and then the planned value, and then we square it, and then we sum all of these offsets, right? So when the difference is then the offset, which can be positive or negative depending on which one is higher, the planned value or the model value, and then we square it to remove all of the negatives, and then we square, and then we sum of the square, and then that's how we get to this, and then we minimize it, and then the current value is then 81,000. So that's basically it. So we run this. Yeah, right. So it converges, and then we see the results over here, the objective function. So initial value is then 81,000 as you know it, and then the current value is 4. So it's very close now. And then if we see from the full sheet, you can see that it was 1,000. Now it spreads over into like so the error we have the 4 errors or 4 offsets. It's spread over, so the error or the offset is spread over this all 4 measurements. So instead of 1000 in the model, so it says, well, to match the plans perfectly, it should be somewhere around 1001. This is 200. This is now 300. Sorry, this is 199. This is 299, which is 300, 200, as opposed to 500 over here. And then this should be like 503, right? The closest to 500. And I think we can see what should be the split ratio over here. Yeah. So what we saw, this is then the input, our input value in the beginning, right? And then the results is then the results of this data reconciliation basically. So product 1 is then close to 20%. Product 3 now is supposed to 30%. It's close to 50%, and the product 2 is then the other way around, close to 30%. So that's how we use this equation oriented to data reconcile data in Aspen PLUS. So it's just a simple example, but you can expand it to much more complicated situations. So see you next time.